All right, good. So that's factorial. And it does come up, as you'll see here, for instance, if we go back to our password example, right? Now we're going to make a 5-digit password, a password that's 5 digits long. But now, okay, let's say any of these digits is a possibility. So we can use 10 possible digits. Now, how many possible passwords can we make if repetition is not allowed? So we're not allowing repetition. Well, again, it's really just a counting principle, right? Each of these digits for the password, right? The password is 5 digits long. Each of these would be like a category. So for the first one, there are 10 possible digits to choose from, right? First category is handled. Next, you would have 9 digits to choose from, because again, there's no repetition allowed. You have 8 possible digits for the third choice, and then 7, and then 6, which is down here. So the total number would be this. And this is actually the same as this quotient, 10 factorial, but you're dividing by 5 factorial. And that turns out to be this number, 30,240. Now, since this is a password, okay, since this is a password, order does matter. You know, if you do 1, 2, 3, 4, and 5, that's different than 1, 3, 2, 4, 5. You know, if you change the order, it's a different password technically. And no repetitions allowed. Well, this kind of situation will come up a lot. If you have, you know, in this case, 10 digits, you're choosing 5 of them, and you're listing them like this. You don't care about order, makes a difference, but there's no repetition. Well, this kind of situation comes up a lot. We have what's called permutation. We have what's called a permutation. Basically, if repetition is not allowed, people also say without replacement. So once you choose one of the digits, you can't use it again. And let's say the order of selection matters. So the order matters, in other words. We actually have what's called a permutation. Namely, if we have, say, n possibilities, and we're arranging r of those n possibilities in order, again, without replacement. Okay? So we have n possibilities. So in this case, we had 10 possible digits. We're arranging 5 of them, right? In this case, we're arranging r of them. Well, the total number of possible arrangements would be this. The total number of ways you can pull this off. You can list r of these n possibilities without repetition and where order matters. The total number of ways to do that is this. The total number of ways you can do that. It's really the same thing as over here. When you have 10 and 5, it's the same idea. Here it's n factorial divided by n minus r factorial. I know this one looks a little scary, what I have here, but it's really just the same as this. And in fact, really, you don't have to memorize this because you really just have to know it's a permutation. Namely, we have a permutation of size r that may be selected among n choices. So in other words, when you have n possibilities and you want to make an arrangement of r of them without repetition, and order matters, so the order you do care about, we say then that there are P of n comma r permutations of size r that may be selected among n choices. And again, this is without replacement when order matters. And this is denoted by this here. So this is how many permutations of size r you can make from n choices. And that's equal to this here. This is not the notation, though, they use in the book. What they use in the book, they do subscript n, capital P, then a subscript r, which is actually what they use on Desmos as well. I just like this notation better, also because I couldn't do their notation on PowerPoint. But again, if you have n choices and you want to make an arrangement of size r, that is of r of them, and there's no repetition, so there's no replacement, and order matters, then the number of ways to do that, those are permutations, so the number of ways to pull that off is this. That's what I'm trying to say here. And again, you can, I mean, you don't have to memorize this anyway, but Desmos actually has this in their calculator. I think other calculators have it too. I think graphing calculators do, but I know Desmos has this capability. I mean, the notation they use is this, NPR. Right. You know, basically what happens is you're going to press this key, and then you'll type in what n is, then a comma, then you'll type what r is. And that'll give it to you. So if we go back to this, this is actually a permutation of 5 items among 10 choices. You know, wasn't going to do this. Let me do this though. Let me show you this. Was everyone able to see the slide?
Yes.
Oh, okay, I got nervous. I thought like I meant what?
I also said yes.
All right, good. I got scared. I thought like, okay, I got scared for a minute. All right. Anyway, let me show you Desmos actually. And let me just stop. Now I gotta stop sharing this. You know, if during the lecture you can't see the slide, please, you know, say something. Anyone, okay? Otherwise, I'll just assume you can see it. All right. So we're in Desmos. If you go to Math, let me see. Yeah. Okay. Good. So I'm on Desmos.com. If you click on Math Tools, like I'm doing, and hopefully, yeah, there it is. Not graphing, but if you go to Scientific Calculator, you'll have this. Then if you click on, let's see, FUNC for function, you'll see down here, NPR. I know in the app you can get this as well. I think it's under stats though, but it is in there. So for instance, if you type this, right? Then you want to type in whatever your n is. So you would type n in parentheses, so n, then comma, then 5, close parentheses, and you'll get the amount over here. You could press enter if you want, it'll come up here. So that's what NPR is. That's how many permutations of size of 5 items there are among 10 possibilities. Yeah.
So if we get a question like this on a test and we have to show the work for it, is it all right to like show Desmos, or do you want us to like write it all out, or what's your preferred method?
You could just write out NPR or P of NR and then just use Desmos, because I'm going to know you use Desmos. So
Thank you.
you're welcome. It's a good question. So I know it's a lot to calculate. So if you just want to use Desmos for that kind of question, that's fine. Yeah. Someone else had a question?
Yeah, just for Desmos, like when I go to Desmos, it just goes to like the graphing calculator part, and I can never get to like the actual just regular like calculator part of it. Like, I don't know why.
If you're in the graphing calculator here, right?
Yeah, like I don't know how to get out of that. Like whenever
let
I
me
just
see.
click on Desmos on my my
Click
laptop,
on,
it
if you click
immediately
on
goes to
this,
this.
if you click on the menu thing here, then if you click on, I think it's your name over here, you could try signing out. I think that would do it. Let me see something though. I think that would do it. You could try signing out. That might help. I think. No, it doesn't do it. You're typing in, what happens is you're typing in desmos.com and then there's a backslash and it says calculator. Maybe take the calculator part off.
Yeah.
That should do it.
Okay, yeah, I think that works.
Okay, good.
Appreciate
Okay.
it.
You're
Yeah,
welcome.
because just
Good
the last
question.
test, I was using my like calculator,
Okay.
like within one of the tests or something like that, my phone calculator, but it's kind of hard to do.
Okay. Sorry, I just want to keep lecturing. Okay, so sorry to cut you off like that. Okay, so any other questions? Okay, sorry if I cut you off like that. I just really want to keep lecturing. So, all right. Anyway, let me see. Okay, so that's what this is. So, permutations. Let's take this. Let's get back to the lecture notes. Go back to that. Okay, good. But now let's do this. Let's see. Well, we did that. Here we are. What if instead, though, the order matters, okay? But we are allowed to have repetition now. We actually saw that. Let me get back to it here in part 1 here. So the order does matter, but we allow repetition. Well, it's just like what happens over here. You're making a 5-digit password, okay? You're making a 5-digit password, right? But each one, since you're allowing repetition, there's n choices, or in this case, 5. So in that case, we have order, but repetition's allowed. Well, in that case, the total number of possible arrangements would be this, n to the r. So if we are arranging our items out of n possibilities, right? So we have n possibilities. We're arranging r of them. The order does matter, but repetition is allowed. Then we have n to the r. And again, it's just a basic counting rule. Essentially, for each choice you have, for each item in that list, okay? Each item you have n choices. So essentially, you're just using the counting principle. All right. Okay, so let's do some examples. Okay. Wait, let me stop recording.